Okay, this is the airplane problem, right? Highly accurate here, right? There's the mass of the airplane, which is a very, very lightweight airplane, and it's going extremely slowly, but it fires this shell forward at 890 meters per second, right? So here's the airplane before flying along. Looks like a cruise missile. Got to put wings on it, right? That's a terrible airplane. Okay, so this is flying at 52 meters per second, right? And it's a 2,450 kilogram airplane. Presumably it's got that shell in it, and that's included in the mass, right? Okay, and then afterwards, you know, here it is. It fires that shell off, right? Apparently it changes shape, right? So here's the picture of it. Okay, and it's got this shell, and a shell is, by the way, like a bullet. Okay, so there it is. It's a ginormous shell. So this is 5.120 kilograms, right? Okay, and now the mass of the airplane is a bit less, right? It's going to be 2450 minus 5.12 is equal to 50 minus 5.12. 2444.88. I like that number. That number makes me happy. Okay, so now here's the airplane having shed some of its mass. Okay, and then this guy's going some velocity. This guy's going 890 meters per second. Okay. I don't know why does that help me think about something? If I can like compartmentalize it, right? So here it is flying along. Presumably, if this shell is flying off ahead of it, this velocity will be somewhat slower, right? So let's just set this up. We've got 2450 times 5240, 52.40, right? Equals 2444.88 times V plus 5.12 times 890, right? Yeah, there we go. Okay, so let's do this. 2450 times 52.4. Holy cow. Okay, and that's 24. And then let's see, 5.12 times 890. Right, okay, so now I'm going to go 128380 minus 4556.8. That's a mere 123,832. Wait, 823.2 equals. Whoops. What am I doing? Okay, equals 2444.8 times V. There we go. So I subtracted this from both sides, so I don't need to write it there anymore. Did I erase that? Good enough, right? And now I just divide. So divide this by 2444.88. I get 50.65, right? I get V equals 50.6459, which would be this, right? Okay, so yeah, the airplane does slow down. In reality, the airplane had way more mass, and the bullets had, of course, much less mass. The airplane that had a problem with this was the one that hunted tanks, and I think it was World War II. And if you want to hunt a tank with an airplane, you get down low so that you can like make sure you're shooting your own, or not, I'm sorry, you're shooting the enemy's tanks, not your tanks, right? And they would get down very low and fire away at these tanks. And of course the tanks would be firing away at them, and everybody would be trying to shoot each other down. It was a very exciting thing. And the person in the front had this giant cannon that they'd fire at the tanks because machine guns don't quite do it, right? And every time they'd fire that gun, the airplane would take a hit on its airspeed, right? And the problem was that there's a speed called the stall speed. That if you go below that speed, the lift created by the wings is less than the weight of the airplane. This is a bad thing for heavier than air flight, right? And so actually it's a bad thing for any kind of flight, right? And so these airplanes would stall. And normally, like a Piper Cub or an ordinary airplane, when they stall, it can be tricky, right? Because you can go into a tailspin or some crazy thing. But usually airplanes will just drop altitude, gain speed, and they're okay. But if you're already, 50 feet above the ground and you stall, you're dead. And so in World War II, they actually put a siren there, or some alarm that monitored the airspeed. And if the airspeed ever got below a certain point, the gunner in the front with that giant cannon, right? They had to quit shooting the cannon because otherwise everybody would die on the airplane. Interesting thing, huh? More than you wanted to know.